All right, so it says the articles students increasingly turn to credit cards. San Luis, I don't know how to say that, Tribune, July 21st, 2006, reported that 37% of college freshmen and 48% of college seniors carry a credit card balance from month to month. Suppose that the reported percentages were based on a random sample of 1,000 college freshmen and 1,000 college seniors. Assume all conditions and all assumptions are met. Construct and interpret a 90% confidence interval for the proportion of college freshmen who carry a credit card balance from month to month. Okay, so first of all, we've got to figure out what the z-score is, right, for 90%. Okay, so we go into our calculator, we hit second vars, inverse norm, and I'm hoping that my people at home are trying that too. And you do 1 minus 0.9 divided by 2, 0, 1. Okay, and so my critical value for that is going to be 1.645. And then we also got to remember that we're trying to find that interval, right? So we're doing the point estimate plus or minus the margin of error. Okay, so our point estimate is 0.37. And our margin of error is our critical value multiplied by the square root of 0.37 times 1 minus 0.37 divided by 1,000. Okay, and so you should get, did I not write this down? Nope. Okay, so I'm going to do this by hand. Fantastic. All right, so 0.37 plus 1.645 square root of 0.37 times 1 minus 0.37 divided by 1,000. And that gives you 0.395.
Oh, that's the answer.
No, you've got 0.37 minus 1 point, because remember we're doing a confidence interval, right? Yeah, so we've got two pieces to it, right? So what? Yeah, it's pretty bad. Darn. Okay, so then you get 0.344, 0.395. Sorry. Put those backwards. It's disrespect. Love it. I know I put something else on my e-class page that has all of that. All right.
What was your after you took the square root?
I put it all in at once. So hang on. You should have gotten something like 5,000. 0.015, something like that. So you're going to say that I am 90% confident that the true proportion of freshmen carrying credit cards is between 0.344 and 0.395. Okay? You're going to do the same thing, but with the college seniors, right? So repeat this process. We do 0.48 plus or minus the critical value multiplied by 0.48 times 1 minus 0.48 divided by 1,000. And again, I would practice plugging this into my calculator because we know at some point they're going to ask us to do that, right? And 645 plus 1.645 times the square root of 0.48 times 0.52 divided by 1,000. And so you should have gotten something like 0.50, let's say 506. And then you should have gotten, correct me if I'm wrong, I'm typing pretty quickly. Divided by 1,000. I got 0.45. So I did 0.48 plus or minus the MOE. Okay. And then again, we're supposed to interpret this, right? So I am 90% confident that the true proportion of seniors carrying credit cards lie between 45.4% and 50.6%. Okay.
What number did you see?
I did 0.48 plus 1.645 times, and this should have been. Are you putting that 1,000 underneath the square root?
No.
That's why.
Wait.
1,000's underneath the, so included inside of the square root. Yeah. It should be. Okay, so you should have gotten 0.015 for this junk right here. And then multiplied by 1.645. That should be 0.025. 0.026 maybe. Yeah.
Yeah.
Okay. Okay. And then in part C, it says explain why the two 90% confidence intervals from part A and part B are not the same width. Okay, so as we can see from here to here, if we subtract 0.395 minus 0.344, this is going to give you 0.051 for the width. And over here, this is going to give you 0.052. Okay, and why is that? Because they have different standard errors. Okay, and what we mean by that is you notice how this square root is different from this square root. 0.37 and 0.48 is going to change it a little bit. Okay, yes. The formula for standard error, just a reminder, I don't know why I separated those words, is the square root of p hat times 1 minus p hat divided by n. Okay? Alright, so I'm just going to pause and take any question. Okay, so on this one, it says the article Doctors Cite Burnout in Mistakes reported that many doctors who are completing the residency have financial struggles that could interfere with training. In a sample of 115 residents, 38 reported that they were working moonlighting jobs, and 22 reported a credit card debt of more than $3,000. Suppose that it's reasonable to consider that this sample of 115 is a random sample of all medical residents in the United States. Construct and interpret a 95% confidence interval for the proportion of U.S. medical residents who are working moonlighting jobs. Okay, so first of all, in order to find p hat, we're going to take how many people are working moonlighting jobs out of the entire sample. So 38 divided by 115, that's going to give us 0.33. Okay, so now we're going to actually construct this interval. So we're going to take 0.33. We're going to add and subtract the critical value multiplied by 0.33 times 1 minus 0.33 divided by 115. Okay, so when we do this, we get, and I'm going to make this easier to interpret. Divided by 115. Okay, so I'm going to take 0.33 and I'm going to add and subtract 0.0859. Okay, so 0.33 plus 0.0859 is going to give me 0.4159. And then I'm going to take 0.33 and subtract 0.859, which is going to give me 0.2441. Okay, so there's your interval. Okay, and then it says to construct and interpret a 90% confidence interval for the proportion of U.S. medical residents who have credit card debts more than $3,000. So if I'm going to do part B, I'm going to say P hat is 22 out of the 115. 22 out of the 115, which is going to give me 0.1913. And again, you're going to take 0.19 plus or minus 1.645, square root of 0.19 times 0.81 divided by 115. When I plug this into my calculator, I'm going to get 0.3217. And then for the other one, I'm going to get 0.0583. Okay. And obviously, if we were going to interpret this, we'd say I'm 90% confident that the true proportion of U.S. medical residents who have credit card debt of more than $3,000 is within those two intervals, right? So when it says interpret, remember you got to write that statement out. I'm not going to write it out right now, but that's how you do it. Now, it does say give 2 reasons why the confidence interval in part A is wider than the confidence interval in part B. So the first reason is that there's a larger critical value. Okay. The second reason is that there's a larger standard error. Okay, so really quick. Larger critical value, we had 1.96 versus 1.645. And then we also had 0.33 versus 0.19. Okay, so that's going to create a difference in this margin of error formula. Okay. Remember, standard error formula is that P hat times 1 minus P hat divided by N. That is your standard error formula. Okay. That's an O now.